Your portfolio probably isn't working. And I don't mean it's bad. I mean, it's not doing the job you think it's doing. Here's how I know. You've got a GitHub with maybe 8, 10, 12 notebooks in it. Titanic survival, iris classification, a COVID dashboard, maybe a Netflix analysis. Each one is clean, each one runs, and you're applying to jobs and hearing nothing. And the advice you keep getting is build more projects, which is exactly wrong, because the problem isn't the number. Here's the uncomfortable thing I want to convince you of today. 12 Kaggle notebooks are worth less than one project that ends in a business decision. Not worth less each, worth less in total. 12 is actually worse than one, and I'll explain why that's not a paradox. So in this video, 3 projects. That's it. That's all you need. I'll tell you exactly what each one has to prove, because they're not interchangeable, and each one is answering a different doubt in the hiring manager's head. Then how to present them so they actually get looked at, because most portfolios die in the first 6 seconds, and it's not because of the analysis. And the mistakes that make a technically good project worthless. And I'm not going to tell you to build a project for a fake company or to redo the same analysis everyone else did but with nicer colors. That's still the student category. If you've been building and not getting called, this is probably the gap. Let's fix it.
First, let me tell you what actually happens to your portfolio, because I think people imagine this completely wrong. You picture someone opening your notebook, reading your code, appreciating your feature engineering. That is not what happens. What happens is this. A hiring manager has 90 applications for one role. It's Thursday evening, they're going through them with a coffee, spending maybe 40 seconds per candidate. They see your link, they click it, and now the clock is running. And it's about 6 seconds before they decide whether to keep scrolling or close the tab. In those 6 seconds, they're not evaluating your skill. They're asking one question. Does this person look like they've done the job? That's it. That's the whole filter. And here's why Kaggle notebooks fail that filter so badly. They don't look like the job. Nobody at work hands you a clean CSV with a well-defined target variable and asks you to maximize accuracy. That's a competition. It isn't the job. So when a hiring manager sees Titanic, they don't think, a data person. They think, a student. And that's a genuinely different category in their head. Not hostile, just not yet. So everything we do today is about escaping that category. And those 6 seconds are almost never spent reading code. They go on your repo name, your README's first 2 lines, and whether a chart is visible without scrolling. That's your whole surface area.
Let me be specific about why the standard portfolio doesn't work, because there are 4 separate failures, and you might only have some of them. Failure 1, zero differentiation. If 10,000 people have done Titanic, your Titanic notebook tells the reader nothing about you. It is literally not information. You could have the best Titanic notebook on the internet and it still says nothing, because they can't tell it's the best in 6 seconds. Failure 2, no question. Most portfolio projects answer nothing. They explore. Here's a heat map, here's a distribution, here's some counts, and then it just stops. There's no finding, no recommendation, nothing anyone could act on. It reads like homework, because it is. Failure 3, the dataset is already clean. So the entire skill of the job, the cleaning, the reconciling, the deciding what to do about missing values, is invisible. You've skipped the part they're hiring for. And failure 4, the quiet one. Volume signals uncertainty. 12 shallow projects tell a reader that you don't know which of your work is good. 3 tell them you have judgment. And judgment is the thing they're actually screening for, because they can teach pandas. There's a 5th failure too, and it's subtle. Every project looks like it took the same amount of thought. When all 12 are the same size and shape, a reader can't tell what you're proud of. Nothing stands out, so nothing gets remembered.
So let me give you the reframe that makes all of this click. Stop thinking of a project as a thing you build. Start thinking of it as an argument you're making. Every project should be arguing, I can do this job, here's the evidence. And an argument has a conclusion. That's the piece that's missing from almost every portfolio I see. Here's a test you can run on your existing work right now. For each project, try to finish this sentence in one line. I analyzed blank and found blank, which means the business should blank. If you can't finish that sentence, the project isn't finished. It doesn't matter how good the code is. Let me show you the difference.
Weak version. I analyze the e-commerce dataset and explored customer behavior patterns. That's a description of activity. Nobody cares. Strong version. 31% of revenue comes from customers who buy in the first week and never return. So the retention effort should move from month 3 to week 1. Same data. Completely different signal. One says, I know pandas. The other says, I can find money. And here's the thing. The second one doesn't require harder analysis. It requires you to finish the thought and commit to saying something. And notice what the strong version contains. A number, a time frame, and a specific action. Those 3 things make you sound like someone who has worked, not someone who has studied.
Right, the 3 projects. And they're in a deliberate order because each one answers a different doubt. Project 1, the business decision project. This is your anchor. And if you only build one thing, build this. The doubt it answers is, can this person turn data into a decision? Here's the shape of it. Start with a question a real business would actually pay to answer. Not what patterns exist in this data. Something like, which customers are about to leave and what should we do about them? Or which of our 5 marketing channels is actually working, once you account for the fact that some customers would have bought anyway. Then do the analysis. It does not need to be complicated. Honestly, a group by a couple of well-chosen segments and a clear comparison beats a neural network here. And then the bit that matters. State a recommendation in plain language with a number attached. We should shift spend from channel A to channel C because C brings customers worth about 40% more over 12 months. And then, and almost nobody does this, state what would change your mind. Say, this assumes the attribution window is correct. That single sentence makes you look senior because it shows you know your analysis has limits. One practical note on picking the question. Choose a domain you actually understand a little because domain knowledge is what lets you notice when a number is implausible. Your instinct for what's normal is worth more than another algorithm. Project 2, the messy data project. And the doubt this one answers is, can this person survive contact with real data? Because everything you've done so far has been on clean data and your interviewer knows it. Here's what you do. Find data that is genuinely horrible. Government open data portals are perfect for this, and I mean that sincerely. Municipal spending records, public health data, transport records. These are wonderful because they are real, which means they are a disaster. Inconsistent category names, dates in 3 different formats in the same column, numbers stored as text with commas in them, duplicate rows that aren't quite duplicates, missing values that mean 4 different things. And here is the crucial part, and this is the thing people get wrong. The deliverable is not the clean data set. The deliverable is the documentation of your decisions. Write down what you found and what you chose. Say there were 2,000 rows with a negative amount, I checked a sample and they appeared to be refunds, so I kept them and flagged them rather than deleting them. That paragraph is worth more than your entire model because it's exactly what the job is. It shows judgment under ambiguity, and that is the single hardest thing to teach. And a trick that makes this much stronger. Keep a log of every weird thing you find. Put the top 5 in your README under what was wrong with this data. People read that section. Project 3, the depth project. And the doubt here is this person actually good or just broad? Because after 2 projects, a reader knows you can do the standard workflow. This one proves you can go further than the tutorial. And there are a few ways to do it, so pick whichever fits the job you want. Option 1. Pick a technique properly and go deep. Cohort analysis, retention curves, A/B test analysis done correctly, including the part where you talk about whether the sample size was ever adequate. Time series with actual seasonality handling. Option 2. Build something reusable. Take the cleaning you did in Project 2, pull it out into a proper Python module with functions and tests, and show that you can write code someone else could run. That signals engineering maturity, which is rarer than analysis skill. Option 3, and this is my favorite because it's the most memorable. Do a small original piece of work on data nobody has analyzed. Scrape something. Combine 2 public datasets that nobody thought to join. The analysis can be simple. The originality carries it. Because here's the thing about this project. Its real job is to be the one they remember and ask you about in the interview. Whichever option you choose, keep the scope small. A narrow thing done thoroughly beats a broad thing done partially. And it's much easier to talk about for 10 minutes in an interview without running out of depth. Depth is the whole point of this one. Now, presentation. And I need you to take this seriously, because I'd say presentation is worth more than half the value of your portfolio, and it's the part everyone skips. Rule 1. Your README is the project, not the notebook, the README. Most people write a README that says, this project analyzes sales data, requirements, pandas, numpy. That's useless. Here's the structure that works, and it's short. Start with the finding. 1 or 2 sentences at the very top before anything else. What did you discover and what should someone do about it? Then the question. Why did you look at this? Then the data, where it came from and how bad it was. Then the approach. 3 or 4 bullets, plain language, not a code dump. Then what you do next with more time. That last one is genuinely powerful because it shows you know the work isn't finished. Rule 2. Put a picture at the top. One chart embedded in the README that shows the main finding. People are visual and they're lazy, including me. Rule 3. Your repository names should say what the project is, not what dataset it used. And Rule 4. Pin your 3 projects on your GitHub profile. Everything else, archive it. And one last presentation rule. Write the README as if the reader will never open the notebook, because most of them won't. If your README alone doesn't convince someone you can do the job, the project isn't finished, no matter how good the code underneath it is. Let me give you the mistakes that make a technically good project worthless, because I see all of these constantly. 1. The notebook with 40 cells and no text. If there's no markdown explaining what you're doing and why, nobody will read it. Add a sentence before each section. 2. Cells run out of order. It works on your screen and errors for everyone else. Restart and run all before you push. Every time. 3. Predicting something with no value. You built a model that predicts a thing nobody needs predicted. Ask, who would use this and for what? 4. Accuracy with no baseline. 94% accuracy sounds great until someone notices the classes are 94% imbalanced and predicting no would do the same. Always state the baseline. 5. Charts with no titles or units. Instant amateur signal. 6. No conclusion. We covered this. It's the big one. 7. Hard-coded file paths from your laptop. And 8. Building projects nobody asked about instead of applying. At some point, more portfolio is procrastination. 3 projects, then apply. And on Kaggle, to be fair, it isn't useless. It's genuinely good for learning technique. It's just not evidence of employability, and people confuse the two. And a 9th, which is really a mindset. Treating the portfolio as finished. Your best project 6 months from now should embarrass your best project today. And when it does, replace it. A portfolio is a living thing, not a monument. So let me leave you with a plan you could actually start this weekend. Week 1. Pick a business question you find genuinely interesting. Find data that touches it and do project 1. Analysis, finding, recommendation, and a line about what would change your mind. Week 2. Go and find something horrible on a government data portal and do project 2. Document every cleaning decision as you make it, not afterwards, because you will forget your reasoning. Week 3. Pick your depth project based on the jobs you're targeting and write all 3 READMEs properly. Then stop and start applying. Quick recap. A portfolio is an argument, not a gallery. 3 projects, each answering a different doubt. Can you make a decision? Can you handle mess? Are you actually good? Every project ends in a recommendation with a number. The README does the persuading, not the notebook. And your quality bar is set by your weakest pinned project, so archive the rest. Here's my challenge. Open your best project and try to finish that sentence. I analyzed blank, found blank, so the business should blank. If you can't, that's your next hour of work. And a final thought. The people who get hired aren't the ones with the fanciest technique. They're the ones whose work makes a stranger think, I can picture this person explaining it to my boss. If this helped, subscribe and tell me in the comments what your project 1 is going to be. See you in the next one.